Hey folks, Doug Blake with Body Design University. Welcome to another weekly study. And today I want to go over the McGill's Torso Muscular Endurance Test. It's an assessment that you'll find in the, obviously the assessments testing portion in the sixth edition of the ACE textbook. And it came from a post in the Facebook group. Again, great way to ask a question because look, for the most part, you're probably going to be having issues and concerns and struggles with these actual questions that ACE is asking, and they don't ask easy questions, and they believe it or not, seldom ask straightforward definitional questions or from essentially rote memorization, which to a certain extent this particular post is referring to. So again, it's the McGill's test. There's a lot to think about when it comes to this concept of assessments and testing. And ACE did a great job by essentially saying to the trainer, and totally agree with this, is that not every assessment and test is necessary. In fact, sometimes doing lots of testing and assessments can be a barrier to entry into exercise because folks just don't want to have any part. They just want to exercise and work out, and they don't want to be doing a bunch of testing, things like that. And it's warranted then to consider whether or not you even do some of these tests. But if you do decide to do it, the McGill's torso muscular endurance test is designed to determine if there are any discrepancies between the anterior, posterior, and lateral or oblique elements in your torso. In other words, the flexion component of the spinal column, the extension component of the spinal column, and the oblique movement patterns of the spinal column, or the side component. So it's pretty straightforward conceptually at the end of the day, and that's why this question is a great question. It's important to understand that you would run a test like this if for some reason you thought it was necessary to see a little bit more specifically what the issues are that a person might be having when it comes to their core stabilization. So remember, the torso test, the McGill's torso test, is designed to determine if there are any abnormalities or discrepancies in the ability of the front, the back, and the side areas of your torso to maintain static stability. Okay, not dynamic stability, right? Movement. Understanding static stabilization, the ability of those muscles in the front, right? The muscles of flexion in the front part of your body, the muscles of extension in the posterior part, and those muscles that are designed to kind of hold you in place obliquely. Okay, how well do those muscles do in holding you rigidly in place? And that's what the test does, right? So there's, basically four things you would do, right? You would do the holding sit up, and that's endurance, right? Then you would do a prone extension test to determine how much endurance your erector spinae and extensor muscles have. And then you would do a side plank bridge on the right side plank on the left side, and you would get a score in seconds. And that's the idea. When you read through it, don't let it, none of these assessments, please don't let them get you so crazy that you're thinking, oh my God, am I going to do this? Am I ever going to do this with average clients? The answer is no, probably not. But if you do, it's there for you to use. Now, let me go ahead and, because I can probably keep talking about it this way. Let me go ahead and get our PowerPoint up. So in reality, the study today is really more on questions dealing with calculations, even though it's specific to the McGill torso test. Look, the questions related to this particular test is going to be like questions related to any other questions related to having to do calculations. And I see this all the time, and I'm asked all the time, how can they give us a question that requires a calculator? And the answer is they don't give you questions that require calculators. They give you questions using math, but all they really want to know is, do you understand the basic concepts? And that's what I want to go over with you. So really, we're talking about questions dealing with calculation. So here is the post, and it was simply a question related to during the muscular endurance test battery, right? It's a 4 test battery, right? Flexion, extension, side, right? That's all it is. And you just timing how long it takes for a person to lose static stability in these different positions, right? And once they lose it, boom, that's the number of seconds, 100 seconds, 120 seconds, 80 seconds, 150 questions. And this question, I'm sure most of you have seen it, the client's flexion score. So there's 4 scores in the McGill's test. Now, this is rote memorization. This is the stuff that you write down when you're going through the textbook. You write down. There's 4 scores, McGill's test. 4 scores. One is flexion, one is extension, one is left side, one is right side, the bridge or the plank. And that's it. There's 4 scores that you get. And then all they want you to do is to do some ratios. That's the math. And so is it difficult math? Technically, no, it should not be difficult. You can do most of this in your head. And if you can't, then you just guess, right? And that's what a lot of the questions are going to be anyway. If you got to guess, you got to guess. Better to guess from two answers than from 4 answers. That's what I'm going to show you here. So the flexion score is 120 seconds, and the flexion extension ratio score is 0.8. Now, if you know the test and you understand what the ratios are asking, your answer is literally right in front of you. If the flexion over extension ratio, so the number of seconds for flexion or the flexion score over, remember, that's the numerator. Remember this from high school math or junior high or whatever. You have a ratio, which is basically just a fraction. The numerator on top, denominator on the bottom. If 120, the number 120 is on top, that's the flexion score. And the extension score, which you don't know, is X, that's equal to 0.8. Then from a math perspective, what do you know automatically? If you don't know what the actual number is, what do we know automatically? Well, if the ratio is less than 1, right, it's 0.8, then we know that the denominator has to be bigger than the numerator. So you could simply guess right now without even knowing anything. You could guess, let me go ahead and put the laser pointer on here. You could guess that the answer has to be either 150 or 180. So now if you had to guess because you still didn't know and you wanted to move on to the next question, pick between these two. You got a 50-50 chance. At least there you got 50-50 chance. But if you didn't even realize that the flexion extension ratio of 0.8 has to have a number bigger than 120 in the denominator, then you're going to choose one of these guys. Now you've got a 25% chance. So on that side of it, I'm just giving you the tip. If you don't know and you're still not studying fully and you're just trying to get through it and you see a question like this, just understand the math component of it is pretty straightforward. If that's the numerator and the answer ratio-wise is less than 1, then the denominator of the fraction must be bigger than the numerator, right? So it's 150 or it's 180. Now, if you can take the next logical step and go 80%, 0.8 is 80%, that looks to be a little bit closer. 120 over 150, 12 over 15 is about 80%, yeah, versus 120 over 180, which is about 0.6, something like that. Can't do it in my head right now. So that's one way to look at this. If you want the answer from that perspective, easy. Calculations, anytime you see a calculation, forget the fact that it's the McGill's torso. Don't worry about that. The fact is you have 120 seconds, flexion, don't know extension. It's just you're calculating X, right? And that equals 0.8. I know it'd be nicer to have a piece of paper to do. Well, you don't get that in the ACE exam. You have to kind of do it in your head and you take a guesstimate, probably 150, okay? So that's that part of it. Now, let me go ahead and move on. Why math? Here's some questions. These are just some basic questions that I'm throwing in here. Why? I mean, I want you to take a step back for a minute. Why math? Why do they even do this? It's not to see whether or not you passed algebra and geometry. That's not why ACE is doing this. What ACE wants you to prove, so to speak, is that you read through the textbook and you understand the basic concept of what the McGill's torso test is trying to get. And the only way they can do that is by using math, is by using numbers, 120, right? 150, whatever those numbers are. So that's why they're using math, because if you understand what the McGill's torso test is testing, it makes sense. And I'm going to show you on that next slide that basically all you're doing from a memorization standpoint is memorizing the three ratios. But if you understand why those three ratios are the way they are, then it makes it a little bit easier to navigate a question like this. What is the question asking? The question is not asking whether or not you can do 120 over x equals 0.8, 0.8x equals 120. No. That's not what they're asking. The question is asking, did you read through that part of the textbook? Did you understand that the flexion extension ratio needs to be less than 1, and that if it's less than 1, that the extension number is going to be bigger than the flexion number? Did you get that? Did you get the idea that the lower back extensors are going to have a higher, for the average person, is going to have a higher endurance capacity than both the flexion or the anterior part of the body or the oblique parts of the torso? In other words, did you get the idea that the average person should be able to hold, from an endurance perspective, a extended position longer than endurance capabilities for the flexion abdominals, hip flexors, and or the obliques? Did you get that? That's what you have to get. If you know that part of it, then for sure an answer of either one of these, 120 or 95, just doesn't make any sense. If the flexion number is 100, the extension number for the average person ideally is less than 1, as you can see, 0.8. The number has to be bigger than if it was 100 seconds or 120 seconds. So that's what the question is asking. Remember, ACE wants to know, did you read the textbook? Do you get the idea? Do you get the concept of what the test is asking? I'm not saying you'll ever use, by the way, I'm not saying you'll ever use the McGill's torso test. We would do it, or we used to use it literally just for athletes. And very rarely, even then, it was for performance to understand basic stabilization abilities. So if you've got unilateral movement, you got people doing the shot put or the discus or the javelin, they tend to overwork, overstrengthen one side of the body from a rotational perspective. Well, you have to know, for the most part, what happened during the season. Did we lose some basic functionality because of throwing it with one arm all the time? So it's not a bad test to get an idea. It gives you a little better understanding of what happened to your athlete. You can also use it for corrective exercise. What is its importance? That's it. Are you really going to use this stuff in the real world? See, these are some of the questions you're asking. You get frustrated. You're like, oh man, am I really going to use this for the average personal trainer, particularly doing group training? Oh no, you'll never use it. I've never used it as a personal fitness trainer. Okay. But doesn't mean it's not bad to know. It's actually good to know. And by the way, they have it in their textbook and they're going to ask questions on it. So you need to know it anyway, whether or not you actually use it. Okay. So those are some basic questions. And so the idea then is that calculation questions are going to be thrown at you. The McGill's torso, and because they're going to get thrown at you, here's what I want you to know at the end of the day with the McGill's torso test itself. There's 3 ratios that you have to memorize. And this is what I would do. If I were you, I would simply write it down over and over, just like anything else with memorization. Because the scoring involves these 4 numbers, there's going to be 3 ratios, right? In other words, front, back, and side static endurance. Those are the numbers you get. So you have 3 ratios. Don't let this confuse you. There's a flexion extension ratio, okay? Then there's a side-side ratio, right? And then there is a side, either side, extension ratio. So those are your 3 ratios. Write them down. Flexion, extension, flexion, extension. And here's the concept. Your lower back should have better endurance than the front, than the flexion components of your torso. That's it. So therefore, if I can hold a statically loaded extended position, and you can see it in the photos, they're facing down and they're on a bench and they hold that, right? They lift up and they're doing the extension movement, right? And they hold it for that number should be higher than the abdominal or crunch sit-up position statically held. That's all. Your lower back muscles should have greater endurance than the other parts of your torso. That's what it means. With that said, any ratio where the extension, right? You got two ratios with extension. There's flexion extension and side bridge extension. Those numbers need to be below 1, but here is your specific point of memorization. Your flexion extension ratio should be just less than 1.0. It doesn't matter technically what that is. It could be 0.9, 0.8, 0.7, 0.75. It doesn't matter. For the memorization component of it, which is what this question is asking, it just needs to be less than 1. And in this case, it was 0.8. That's all. That's what you have to remember. Flexion extension is less than 1.0. Side to side, you should have the same level of endurance, all things being equal. Everybody's a little bit different. But ideally, your left side endurance ability from a plank should basically be the same as the right side. Why would it not? Well, there are some minor functional differences in everyone's body. So there's a little bit of leeway, so to speak. Ideally, your left and right side or your right and left side should be 1.0. But if it's not, and it's off a little bit, that's okay. And that's why you have this ratio of either 0.95 up to 1.05. In other words, there can be a 0.05 difference in the endurance capability. So in other words, you do a plank on your left side and it takes 80 seconds before you fatigue out. And then you go to the right side and it's 83 seconds. Well, that's acceptable, right? That's acceptable because 80 seconds divided by 83 seconds keeps you well within this this parameter, right? And then there's the side to the back. Okay, so you basically take the 80 seconds where I fatigued out on the left side, and that's going to be my numerator. And then I have 150 seconds on my extensor, right? My extensors should always, for the most part, be more endurance capable than my side, than the oblique components of stabilization, that musculature. And so not only does it need to be less than 1, but it should be significantly less than 1. Okay. In other words, it should be below 0.75, your ratio. So what are your numbers? 1, less than 1, less than 0.75, and then the side to side should basically be equal to 1, but we know there's a little discrepancy. So 0.95 to 1.05. Do not let those numbers scare you. Those are your three things you have to remember from a pure memorization perspective when it comes to questions like this. Remember, if you want to understand the McGill's test itself, that's one thing. And that's why I went over it that much with you. If you want to understand the concept of why it's done, it's a really good idea to understand some of these things, whether or not you do the test or not. So understanding why they're asking that question makes it easier to navigate a particular question like that. If you're not interested in any of this, you really don't care, you just want to pass that darn test and you just wanted to understand what the question was asking, I get that too, for sure. Not an issue. In that case, it's really simple. Flexion extension, it's just a math problem. 120 over x equals 0.8. Okay, it simply means that the denominator has to be bigger than the numerator. The numerator is 120. The denominator needs to be bigger than the numerator to give you a 0.8. There was only 2 answers in there that gave you numbers bigger than 120. Now you have to decide, is it 150 or 180? What's closer to 80%? It's going to be 150. Okay. And that's how you would deal with questions like that. It's a really good question, by the way. And by the way, I hope this was helpful. At the end of the day, this is all about memorization. How well do you memorize? Please don't tell me that you have trouble with math. It's not a math issue. Okay. Unless you're good at math and you can simply do that in your head. They want to make sure you understand the concept. Okay. So I hope it was helpful. And if not, just leave some comments. Let me know that this was a struggle and you need to know more about it, or another particular assessment, more than happy to do a weekly study on it. Remember, we want to help you to pass your ACE exam on the first attempt. But remember, the only way we can really get you through that is if you're asking us questions, so I can kind of pick it apart like I did with this particular post. Remember, Q&A with Doug and Corey every Wednesday at 2 p.m. Eastern time. And then, of course, every week we get one of these studies out there. Just let us know how we can help you. I mean, that's really the whole point of this, is we want to help you to get to the point where you can take that ACE exam and pass it on the first attempt. So have a great weekend, and we'll see you next week. Thanks.